Hi, now we will discuss an example for one-way layout. So we use the iris data. So this is the most famous data. And this data set have the 4 variables and the 1 factor variable. So we think about the sepal length. So this as variable. So we have x. And we have the factor. Factor is the species. We have 3 species, the Setosa and Versicolor and Virginica. So we have the 3 levels. So we analyze the sepal lengths by species. So at first, think about the box plot. The plot sepal lengths by species. Then that makes this graph. So Setosa, Versicolor, and Virginica, and this is sepal lengths. You can see the obvious difference between these 3 groups. The box represents the center 50% of the data, and the box plot that represents maybe the 1.5 times basically the height of this pin. So you can see that the even the overlap is limited. So the Setosa is almost entirely below the Versicolor and the Virginica. And the Versicolor and the Virginica, we have some overlap, but still clearly the average level is different. So species can explain much of the variation in sepal lengths. So if we combine these 3 groups, then we have larger variability, but we use the one-way layout model, then we use species that the species explain the most of the sepal lengths. Okay, so now that we fit the sepal lengths on species, so this is one-way layout, then the result is here. So intercept, so this is basically the model, the xij is equal to mu plus alpha I plus epsilon ij, and alpha 1 is equal to 0. So this is the model we fit. And intercept is mu. And this one is alpha 1, and this one is, sorry, alpha 2, and this one is alpha 3. And you can see that the Setosa was the first group, but only the variables are Versicolor and Virginica. So here are the estimates. So these are the mu hat, basically, and alpha 2 hat and alpha 2 hat, alpha 3 hat. And you can see the standard error and also t-values here. So this means that the Setosa, the first group, is the baseline. So Setosa species has the mean sepal length of the 5.006, so here. And mean for Versicolor is 0.93, larger than mu hat, so 5.00. So that is 5.936 on average. And the difference between the first level, the Setosa and the Versicolor, is significant because we have the p-value less than 8.7 times 10 to the power negative 16. So it's highly significant. You can see that if the t-value is usually larger than 2 or so, then it's significant at 5% level. So it's 9, so it's pretty large. So Versicolor is significantly larger than the Setosa. And also you can see the Virginica. The Virginica is basically the mean level of the Virginica of the sepal length is the 1.58 plus 5.006. So that is 6.588. So that is the mean sepal length for the Virginica species. And this is even more significant. So because the Virginica is largest and the Setosa is smallest, and the p-value here. And now that we want to test if alpha 1 is equal to alpha 2 is equal to alpha 3. So this is, maybe I have to clarify the 2 different models. So maybe we put tilde. So xij is equal to y alpha I tilde plus epsilon ij. Then our null hypothesis is this. But now that we have representation of mu plus alpha I plus epsilon ij with alpha 1 is equal to 0. So that means that alpha 2 is equal to alpha 3 is equal to 0. So this is the null hypothesis we want to test. So F value is reported here that we defined this in a video, the first video in this chapter. And degrees of freedom is the 2 and 147. You can see the mean square error. So you can see this is SSD and this is MS for the species residuals. So this is the species. So this is the between, and the residual is the within residual, so B and W. So you calculate the mean square. So at first, the sum of squares, then we divide this by the degrees of freedom, then we get the mean square. So 63 divided by 2 is 31.5. And then the same thing for residual, 38.95 divided by 147. So that becomes 0.265. Then we take the ratio 31.6 over 0.265. So this becomes 119. So this is extremely large because the F value is usually centered around 1. So 119 is really large. So the p value is very small. We reject null hypothesis. Yeah, so this is how to implement the one-way layout in the R language. So basically, we have the same function, LM function. Then after that, we can use the ANOVA function to do F test.